right, amazing students. We are going to begin a new section, section 3.2 and 3.2.1. Go ahead and start by writing your name. We're in a new section where we're going to go ahead and put away our patty paper. You know, all those shapes that we've been drawing on patty papers lately, rotating, reflecting, translating, and we're going to move on to algebra tiles. I know many of you have used algebra tiles in the past, and it's our time to go back to them and learn more about them. These will be on our upcoming quiz or test, so pay attention and take very good notes. So you can also write the date and the period. We're going to go ahead and begin reading the essential question. Here we go. How can algebra tiles help me add and multiply? Modeling area and perimeter with algebra tiles. Let's continue reading. In previous math courses, you worked with areas and perimeters. Ooh, okay, areas and perimeters of shapes made up of rectangles. Today, you will find the areas and perimeters of shapes made of rectangular algebra tiles. Haha, nice. Let us begin. Question 373. Question 373 says, for each of the tiles shown, label the length and the width, then write an equation relating the length to the width. So, what's the area of a square? Let's just go ahead and take a little note here. An area of, you can write the capital A, of a square equals length times width. Some people also consider it to be side times side, since the two sides are the same. That would be side squared. But we can also just consider the area of any rectangle. A square is an example of a rectangle. I'll repeat, a square is an example of a rectangle, and all rectangles have an area of length. Length times, yes, length times width. So we're going to go ahead and complete letters A through E so you can have all the tools you need to be able to do the remaining questions in this lesson. So here we go. Our first tile, the biggest square tile that we can get, is going to be, if you're using physical algebra tiles, it's going to be the y squared tile. So the total area of a y squared tile is y squared, because that's the name of the shape. The name of the shape is the area of the figure. So you can go ahead and see the name of this shape. This one's x squared, typically a little smaller than y squared. The name of the shape is the area of that figure. Why would they call it the y squared tile? Because its area is y squared. Why would they call it the x squared tile? Because its area is x squared. Now, what do you think the area of this one is? That's right. The area of this one, the x tile, the area would be x. The area would be 1. And what's the last one? Yeah, the longer y tile. The y tile goes along with the y squared tile. You see how they're the same length. Yeah, this is going to be an area of y. Now, what length, that's a cursive L, and what width would multiply to get y squared? What times what? Length times width. What length, what width would multiply to get y squared? Y times y. Write that down and label the sides of your shape as well. Y times y would give us, what's y times y? Y squared. What's 4 times 4? 4 squared. What's 8 times 8? 8 squared. What's y times y? Y squared. Okay, the next one is the x squared tile. What times what? What length, L, times width, W, would give us x squared? Of course. You got it. It's x times x. You got it. Good job. All right, but this next one, what would we label the sides to get just x? Okay, the last one was x times x. Notice this is the same size since they're both x. This would be x. Now x times what? Length times width. X times what is x? Yeah. 1 times x, which is just x. You can also say x times 1. The order of the area typically does not matter. Okay, these little dots that I've been drawing, if you've been confused by the dots, that's okay. The dots is just multiplication. Usually you'd write x times using the multiplication symbol, but we don't want to confuse x's with multiplication. We use dots to keep it simple. Okay, next one, the 1 tile is 1 times 1. 1 times 1. I guess I'll write the 1 that way. And finally, the y tile is 1 times y. Let's move on. These are all the tiles that we're going to be using. There is actually another tile that we could use, and we will be using it is the x, y tile, where it combines the length of x and the length of y into a rectangular shape like that. So we could prepare for those ones. The xy tile just has an x squared tile underneath it and a y squared tile that would fit underneath it as well, or a y tile or an x tile next to it. All right, let's move on. Recall that if the tile is unshaded, it represents a negative quantity. What is the area of the figure? What could the sides be? All right, so this one is unshaded, meaning it's just simply not shaded. This is going to be the area of this one would be negative x squared. While the shaded x squared tile, go ahead and draw that. The area would be equal to positive x squared. So that allows us to deal with positive and negative quantities. Okay, next up, problem 373. Combining like terms. You've all seen the word combining like terms. You've done it, you've practiced it. It's now time to work on that with some algebra tiles. It says combining like terms is simply adding expressions that have the same area. For each of the following, write a simplified expression by combining like terms. Use algebra tiles to represent the terms if needed. So the idea here, if you can make a little note here, is you're wanting to add apples with apples. If this looks like an apple, I hope it does. You want to combine apples with apples, and you want to combine bananas with bananas. But you don't want to combine, you don't want to combine apples with bananas. You cannot combine those. So we want to combine the like terms. Like means they're pretty much the same type of tile. They have the same type of area. Okay, so here we go. Let's do the first one, letter A. For letter A, you're welcome to use some color. I'm going to add some color to the first one. So during the time, please grab some highlighters or colors if you have not gotten them out already. I'm going to begin A in about, well, let's pause the video here. Okay, we're back. Letter A. If you see x and x, that means they are like terms. If you see x squared and x squared, they are like terms, including the negative there. And then you'll notice that there is a floating +1. That is not a like term. So I'm going to go ahead and make sure I have these highlighted correctly. If it includes a negative, I do want to include the negative in the highlight just to keep things simple. Okay, alternatively, you could just underline things. Perhaps 1 underline for x, 2 underlines for x squareds, and you can leave that last one just like that. Now, the idea now is to combine the like terms. We want to put the orange ones together. And why did I put orange before yellow? Yeah, which one has a greater area? X squared or X? We typically want the greater area, the higher power of X to go first. So that's going to allow us to rewrite this as 3x squared minus 2x squared, putting the negative with that as well. Now, there is a plus x. If it was negative, it would be minus x, but it's just still positive. And there is in yellow the minus 4x, the combining those like terms. And finally, we have a plus 1 at the end. Now, this next part is very simple. Combining like terms simply means add the apples with the apples and the bananas with the bananas. So if we have 3x squared minus 2x squared, this simply means 3 apples minus 2 apples. I'll say it again. 3x squared minus 2x squared. You can treat it like apples. 3 apples minus 2 apples is just 1 apple. 1x squared. And then let's treat these like the bananas. 1x minus 4x. 1 apple minus 4 apples. Oh, not apples. 1 banana minus 4 bananas. That's going to be negative 3 bananas. So far we have x squared minus 3x. You cannot combine those because this one is an apple. And this one is the banana. And the plus 1 is like saying, oh, we're adding $1. And so you cannot combine any of those. This one is done. Okay, so I'd like for you to work on those remaining problems, letter B, C, and D. We're going to pause the video here and then check our work. Did we get the same answer? I do want to point out I did try letter B and I messed up the colors a lot. So it's pretty important if you do notice something like letter B where it has y squareds, x squareds, y, x, and numbers that you can just simply keep them underlined. For example, 3y squared and 4y squared, you can underline them once. Minus 7, you can perhaps circle that. Plus 8x squared, that's not y squared, so we're going to have 2 underlines. Minus 2y, that's not y squared, so we can put 3 underlines. And then plus 4, we can circle that as well. So what would that give us? You can combine all the like terms. That would give us 7y squared when you combine those two, plus 8x squared, and you can put this in alphabetical order if you want to, minus 2y, and then negative 7 plus 4. Negative 7 plus 4 is negative 3. You cannot combine any of these together because they are not like terms. All right, we're going to check our work for letter C and for letter D. And it's going to show up now. All right, so that is going to be, we're going to stop here for part 1. You can flip your paper once you're ready. We're going to make sure everybody has this in their notes. Our answer here was 6xy minus x squared minus 2x minus 1. And here we had negative 5x plus 0. Negative 5x plus 0 is negative 5x. Let's stop right here.